Hello, today I will be presenting to you rotary tables and dividing heads. I will explore with you what they are and how they work. Workpieces are getting more and more complicated as require circular cuts, fillets, and specific divisions of teeth for gears, for example, which is why rotary tables and dividing heads are important as they can accurately rotate a part at specific angles. These tools are primarily used on milling machines, but can also be used on drill presses, grinders, and boring machines. While both serve similar purposes, they both specify in different operations. So I will start with the dividing head. The dividing head is used in applications where you need to do a certain amount of equal divisions, such as forming squares or hexagons or any type of shape on a workpiece. Or if you want to do gear cutting and you need to divide the teeth at equal spaces, this is when dividing heads come into use. Dividing heads can also tilt from 0 to 90 degrees, which could be useful at some times. So now for the parts of a dividing head, there is the handle, which is what the user uses to rotate the workpiece. At the tip of this handle, there's an index pin, which you put into one of the holes of the index plate. The index plate is super important. It consists of multiple rings of hole rings with different numbers of holes. So in this case, there's 21 here, 33 on top, and it's what allows you to precisely do a fraction of a one revolution. Every time you turn the handle, you are only moving one tooth of this worm wheel, so you need to turn it 40 times to do one full revolution of the workpiece. Also here, there are sector arms, which will be described later. So as mentioned earlier, the ratio of the dividing head is 40 to 1. So if you want to cut, for example, 40 teeth on a workpiece, you need to rotate the handle only once between each cut. To cut 20 teeth, you need to rotate it twice. To cut 80, you need to rotate it one half of a revolution. With this, we can derive a simple formula, which is the number of turns between each cut is equal to the ratio, which is always 40, divided by the number of divisions that you want. So what if you need to cut 24 teeth? Simple, you apply the formula. So the number of turns between each cut is equal to the ratio divided by the number of teeth. And simplifying this gives one full rotation and 2/3 of a rotation. Now, how do you do 2/3 of a rotation accurately? This is when index plates come in handy. To choose the right index plate, you find one where the number of holes is divisible by the denominator of this fraction. For example, we will use 15. Then you multiply the chosen index plate by this fraction to find the number of holes that you will need to go through. So in this case, we start here and you do one full revolution and then you count 10 holes before placing the index pin. Notice that the sector arms here are only here to help the user locate the next hole. So that concludes dividing heads. We now know what they are, how they work, and the applications that they specialize in. Moving on to rotary tables, they are not specialized in dividing work. Rather, they are good at making circular cuts, so they can make circles, fillets, and arcs of a certain length. Now, what's unique about them is that you can put a workpiece of any shape on it and hold it tightly with clamps. That is something you cannot do on a dividing head. Now, some additional cool features about rotary tables is that they can stand up vertically and horizontally. You can also install a three-jaw chuck on it to hold cylindrical pieces. And finally, you can install index plates so that it operates just like a dividing head. So rotary tables work with degrees, minutes, and seconds. The main scale shows a full 360 degree. However, the graduated scale here is more detailed and shows minutes. 60 minutes is equivalent to 1 degree. And in this vernier scale, you can see seconds in increments of 10. And 60 seconds is equal to 1 minute. The resolution is 10 seconds, which means 1 over 360 of a degree, which shows how precise this tool can be. The graduated scale has 460 minutes, and this means that every revolution you will turn this table by only 4 degrees. This leads to a ratio of 90 to 1. So that concluded rotary tables and the applications for which they are normally used for. So this concludes the presentation. We now know how each tool works and the applications that they specialize in.